Okay. Hi there. My name is Julio Garcia Jr., and this is my semester project for Computer Science uh, 2436. And before I go ahead and show you my code, I will go ahead and do a brief run through of the program. So we're going to go ahead and hit play here. And this program is quite simply a journal planner program that takes a user input to create a task list or a journal entry, allowing the user to organize these by date and saving them to files. And of course, it displays a little calendar to keep track of the month. So here we have the main menu. We have three options: journal, tasks, and calendar. And then our fourth option is to exit. The journal entries, we have four options as well: read, write, edit, and return. Let's go ahead and write something. So we have our -1 to return, or we just enter our date. Today's date is 5/10/23, and this is an entry for the video. And we press enter and enter again to save it. And then we can go ahead and see if we can find that. Yeah, there we go, 5/10/2023. And of course some other entries that I've done before. So let's go ahead and view that last entry that I wrote. So 5/10/2023. This is an entry for the video. Okay, cool. So press enter to return. And then we can even edit that entry uh, if we wanted to. 5/10/2023. We get prompted if we want to replace this entry. Yes, let's replace that and enter our new record. This is the replacement record for the video. Press enter, entry updated, press enter to return. And we can read that 5/10/2023. And we can even look at some of the other records for 30/20/23. This is a test record. Let's see if it works. Yeah. So those are some of the, and everything is in order. Let's go ahead and hit return. Next is the tasks. Now, I forgot to mention, when the program starts up, it opens two files and it loads in your entries from the previously existing files. Or when you close this program, it makes new files with your new entries. So let's check out the tasks. Here we have add task, month 5, today's date 10/20/23. Enter task, submit video. Cool. So press enter, enter again, and then we are going to toggle task completion. As you can see, I've already gone to Mother's Day dinner, so let's go ahead and toggle that. And it shows us as complete, and we press enter to return. And then if we wanted to delete tasks, we click here, and we can either press 0 to exit or go back. And since Mother's Day's dinner is completed, we can go ahead and delete that one. And we see the new updated list. And press enter to return. And of course, like as I mentioned, these are in order by date. So 1/10/2023. Go back in time, and then toggle task completion. You see how it got put to the front. We can set that as complete. And there you go. And then press enter to return. And we deleted task and we toggled the task completion. So let's go ahead and return. And then finally we have our calendar display. This should display the calendar for the month. Calendar of 5/20/23. 2023, and we have an option of moving forward or backwards. So let's go ahead and see the calendar for the previous month. And let's see the calendar again for the previous month. And of course, we can go forward. Right? And so we can compare the calendar 5, 10, 20, oh sorry, 5, 10, 23, of course, right there, same date. And we exit. And those are the three main things on this program. We're going to go ahead and exit and check out the code. Now this was a lengthy code for me. I was having issues getting the header files. So I just went ahead and put everything in one file and labeled separations with asterisks. And so we're going to start off with our include libraries, IOStream for the regular used by C++, the fstream for file streams, string to modify strings, sstream to for string streams like file streams, but for strings, stdlib for system, clear, and ctime to tell the actual time. And we begin with our structures. We have two structures, structure entry and structure task. Structure entry is our record, month, day, year, entry left, entry right. This is a node. And structure task is int, day, month, year, string item, and a bool complete. This is just to keep everything together nice and concise and easier to reach. Next we have our objects. We have three objects. We have our journal, which holds our entries. We have our to-do list, which holds our tasks, and then we have our calendar. We have our journal, and our root is set to null. In the very first thing, of course, we see is insert, void insert, very important. Inserts each node record by comparing month, day, and year. Of course, here we have entry, new entry. This new entry gets filled with the record, the month, the day, the year, and the pointers get left and right get set to null. If the root is equal to null, then the root is equal to the new entry. Basically, that is our first entry of the tree. Now we have an entry current is equal to root. This is so we can traverse the tree to input the location. And here we just have a bunch of comparisons of year to current, of the input year to the current year, which is the year of the node. And it goes on and on to include the year and the month and the day. If the year is less than the year, it goes left. First it checks your year, right? And if not, it goes right. Once an empty entry is found, insert the new entry right here. So if current of left is equal to null, current of left is the new entry. Otherwise, it continues to traverse on the left side. And here it checks the year is equal and the month is less than. And it does the same thing, checking the left entry. If the left entry is empty, it inserts the new entry. Otherwise, it keeps searching left. And then here we have the comparison to the date. If the year is the same, the month is the same, then the day is less than, it goes to the left. Here we have a special one. If the year, the month, and the day are all exactly the same, then this is to replace an existing record. There can only be one record per day. And then we have the traverse right nodes if year, month, or day are larger than the entry. Moving forward, we have a search entry. Works very similar to the insert entry by comparing month and years. And this is where our target is. Our target has to be equal to the year, month, and the day. Otherwise, it points to null if the entry does not exist. And this is in entry because we call this later in the code. Load entries. Oh, these functions use the root from the private. Because root is set to private, we have to use these functions to call the private form of these functions and input the root and include the input file or the output file to load or save the entries or just to print. So here we have entry root. Void print private load entries. So we call in the root and the if stream print input file. We call our variables, load in a node information, while getLine reads a line of the text from the file. While getLine reads from the input file and places in the line. While this is happening, the loop goes on. String stream, we convert the string line into a stream variable to read from it. Similar how we read from a file, we read from this line. SS input month, day, year. And get line input file slash line. This reads the line, of course. This reads the line again, and it reads each line at a time and adds it to the record. Line plus new line is equal to record. So that way it makes a string, a single string from several strings. If the line is ever empty, it just breaks. And of course we have the insert function here, and record is set to reset, so that way it can loop again until it is complete. Private print in order. This prints, this works like any other basic node. It prints everything in order. The left node first, then the current node, then the right node. Private save entries. Okay, so this takes the root and the outstream file. If the root is equal to null, just return because there's nothing to save. Otherwise, private save entries root left out file. This saves the leftmost entry first. Then it outfiles the current entry, and then it outfiles the right entry. And the format is as follows. In one line, we're going to save the month, the day, the year, and then the record. Now we have our to-do list. Our to-do list has a structured task, of course, that we built earlier, and there's 100 tasks with an int of count, with a count of int, variable int count. It starts with a count of 0. But of course, we have probably our most important function here, count tasks. Count is set to 0. And for I is equal to 0, I is less than 100, we add to I. And if task of I.item is not empty, we add to the count. This is to ensure that we count all the items in our array. Next, we have load to-do list. If stream input file, string line. This loads an array from a file. Same thing, while getLine is reading from the input file and putting it into the line, we're going to do all this stuff. Here we have character buffers, just to make sure that the input from the file is being read correctly. Stream, line, ss, m-d-y, comma. That is the setup for, that is the file format that we have for our file. And the dash and the comma are just empty fillers that pick up those dashes and those commas and just kind of throws them away. Get line, ss task. This reads the line up to the first comma to store it in the task. So month dash day dash year, comma, right? SS complete. SS complete is our bool. So getLine SS tasks reads every string before the comma. Here we have create the new task. We create our new task, new task, and we set all those items, month, day, year, to the input month, day, year task from the getLine file. And then we assign the new task to the next element in the array from tasks count plus plus new task. Since we had already counted previously, since the count begins at 0, this count and this particular function only happens at the beginning of the program. Count should start at 0, and then it goes all the way up to whatever items we have. Here we have void remove oldest completed task. This is to remove the oldest completed task if for whatever reason you have too many tasks, but I'll explain this a little bit more. uh, of how this is implemented, but for right now, I'll just walk you through it. So we have oldest index is set to -1, oldest year, month, day. This is all set to the max to ensure that it is the oldest. For the oldest completed task, we loop I through the count, and if tasks of I dot complete and task of year, so if the task is complete and the task year is less than the oldest year is equal to I, and we set the new task. And of course, we do the same iteration of checking the year, checking the month, and checking the day. Uh, if everything matches, then we set the new task. Um, and then if the oldest index is not equal to -1, then the int I is set to the oldest index and I is less than count -1, then the task of I is set to the new task and the count is diminished. Here in the enter task, we count the tasks, and this is where we prompt the user if the array is full to replace the oldest task. Array is full, do you want to remove the oldest task? Yes or no? If T upper, this just converts our entry to uppercase, is Y, then we remove the oldest task and oldest completed task removed. Otherwise, no changes are made. Here we prompt the next input. Enter the date for the task or -1 to return. And here we have our month, our day, and our year. And then after we check the month, day of the year, we enter the task. This is to type down the task that we're entering. While get line cin word and dash word, and word is not empty, right? While words are in the input and the empty line is not input, then we add tasks to the word. Basically, while we're typing, as you saw, as we're typing, if we space it and then we go on to the next word, it reads from that typing, and then once we hit enter and enter again, that is when word is empty, and then we stop the loop. And of course, once again, we create the new task, we assign all the items. The new task.complete is set to false because we have not completed that task. And then tasks of count is equal to the new task since we already counted before. Oh, actually, that should be task of count plus 1 because the count is for the total amount of items, and we have to add 1 to ensure that we enter the new task in the correct element. And then we have our start tasks, which is a simple comparison swap. It compares the years, the year is the same, it compares the month is the same, it compares the day. Same, just a simple swap sort. And we have our void toggle status. If we take in the index, if the index is complete is equal to false, then it is set to true, otherwise it's set to false. And we have our display to-do list. Once again, we count the tasks. We loop through the array and display the contents of each element in the for right here. Here we output the month and a dash, the day and a dash, the year, and then we see out a dash, the item, and another dash. And this here checks the bool. If the bool is complete, then it checks complete. Otherwise, it outs incomplete. Delete task. Once again, we count the tasks. If the index is greater than or equal to 0 and the index is less than the count, it is a valid index, and then it moves to fill the element left by the deleted task. So I is set to the index which was input. If for I is less than the count, I++. And basically all this does is once we set the original index, right, index I, to task of index, the next task after it element is moved to its position. Basically, if we were to think about it, a shift of, we remove an element and everything is shifted to the left if we were going from left to right. And then we decrement the count and we output task to delete it, otherwise we output an invalid index. And we have our save to-do list. We just loop through the array while we outfile the month, the day, the year, the item, and the complete. Here we have the calendar. The calendar is month and year in the private. In the calendar, we have these variables which allow us to get the current month. T underscore time now gets the current time from the system and sets it to the now variable. T time is converted with the local time function into a TM structure, and it passes it to the now address. So now is holding the time. And of course, it's set to a variable current. So current time is now. Here we have month is equal to the current month plus 1. This ensures that January is 1, February is 2, instead of January being 0 and February being 1. Year is set to the current year plus 1900. This assigns the correct year because this holds up to the digit up to 1900. Sorry, it holds up to the digit before 1900 is added. So the 1900 is to add to that to ensure we get the correct year. Here we have the bool is leap year to check if the year is a leap year. And it makes multiple checks to check if the year is a leap year. First, it checks if 400 is divisible by 0. If it is, the year is a leap year. It checks if 100 is divisible by 0. If it's not, then if it is, then the year is not a leap year. And then finally, it checks if 4 is equal to 0, and if it is, then the year is a leap year. Otherwise, if it's not, if it doesn't pass these checks, then it is not a leap year. Int get days and month, and this uses int input month and year. It checks if the month is February 1st, if it's a leap year as well. Here's the year. If is leap year, then return 29, otherwise return 28. And then we have the months. If the months are April, June, September, or November, 4, 6, 9, and 11, return 30, otherwise return 31. And then we have get the first day of the month. And this is an interesting algorithm that I found, Zeller's congruence algorithm. You can find this online. It sets the January and February as the 13th and 14th month of the previous year, because I read that instead of starting on 1 and 2, it starts from 3 and on. That's interesting. But if the month is 1 or 2, then month plus equals 12, year minus minus. And then to calculate the day of the week, D is equal to the day of the month, M is equal to the month, K sets the last 2 digits, and J sets the century of the year. And then this is just a very specific algorithm that you can find online that calculates specifically the day of the week. Here we have like the days, the month calculations, the year calculations, and the century calculations, all divided by 7 for the day. And then we convert the result to match the numbering with 0 starting at Saturday, 1 at Sunday, and so on. And we have the print calendar. Here we get int days in month is equal to the get days in month, month and year. We calculate our month and year, we get our days. And then we print out our header, which also displays the month and the year. We determine the first day of the week with int first day of the month, get first day of the month. We print the leading spaces before the day of the month. we print the days of the month, print the day and the number. The day number, if I is less than 10, we give it a space. And then the number. Print new line character if Saturday, otherwise print spaces. So we check the weekday is equal to the first day of the month plus I minus 1, and we divide that by 7 to see if it is a Saturday or not. If weekday ends up being 6, then we see out a new line, otherwise we see out a blank space. And that gives us the space, it gives us the date, the space, the date, the space, the date, weekend is 6, then we print out the new line, and we start over. Here we have print trailing new line character is if it's necessary. If int of last week, day of the month is equal to the first day plus days in month minus 1 divided by 7, and it's not equal to 6, then we output the new line. Here we prompt the user for input, calendar backwards, calendar forward, exit. We take that input, and if the input is equal to 1, we go back a month. If month is January, then month is set to December, year minus minus. Otherwise, month minus minus. If the input is set to 2, month is December, then month is set to January, year plus plus. Otherwise, month plus plus. Finally, the input is equal to 3, then we return and we clear the system. If for whatever reason we complete this, we just return. Here are some of the function prototypes, which I'll talk about afterwards. Main, journal, task, prompt search, prompt search, and prompt enter. We'll just go ahead and jump to those since they're a little bit shorter than the rest of the code. Here at the end, I have to add this, functions. Just that way we have that visual. And these are simple menus. Int menu displays the menu. Journal menu displays the journal menu. Task menu displays our task menu. Prompt enter. There's a couple places where I prompt the user to press enter. Press enter to return, cn.ignore, cn.get. And then the prompt search. There's a couple places where I request the user to search the date. So I just easier to make a function for that. Going back up to the main part of the code. Here are the main function variables. These are the variables which are used pretty much throughout over and over. Our journal, our entry, found journal, found entry. This is going to be used in our search. To-do list or to-do list, calendar. Our ints for month, day, year, and an input, our string for record, line, and word. Here we have the function, the part of the code that loads in the journal entries and the part of the code that loads in the file entries. The to-do list entries. So string of file, to-do list, if stream file 2, and if the file is open, to-do list load the to-do list. And they're pretty much the same. Open the file, read the file, load the file, and close the file. And then main menu loop variables. These are variables to loop that are used with a main loop. System clear CLS to clear the screen. Our initial loop goes and presents our main menu here. Going down, after our main menu displays our options. Our options are write, read, and edit. Right? Journal display. We go on to, if we press 1, we go to write. And here we have an error, a try-catch block that runs to ensure that we are putting valid date and year. If it's out of range, then it throws out the error. Invalid day input, invalid month input. Please enter a valid day. Once all that is done, we hit the cn.ignore to clear anything that's been pressed, so that way we can get line and make our record. So we prompt for the month, the day, and the year. Then we prompt for our record, enter record. And we just journal insert that. end record is reset to blank, so we can use it again. And resume is equal to false, so this loop is ended. And we go on break, return to the journal menu, and then we can click our next entry, which is read. And this one outputs our existing entries. So display entries. It prints the journal in order. These entries are displayed by date. We saw that earlier. The search is prompted. If month is equal to -1, then we break. Otherwise, we searched for the entry. If the entry is found, we search for the entry. If entry is found, then journal entry for the day, and then we read the record. Otherwise, we output entry not found. And we prompt enter again. Here in edit, we display the existing entries. Whoops. Display existing entries. And same thing, same ordeal. We print the entries that are there, and we prompt the search. If the search is found, we are prompted to, if entry is found, we are prompted to replace the record. If we put yes, we are prompted to read the new record right here. Otherwise, we make no change and we prompt enter and then just move on with our lives. And if the entry is not found at all, then entry not found. Just period. Case 4 is just breaks from the loop, takes us back to the previous menu, and the default just outputs an error message. Here in the task menu, we display the task menu. Our options are add task, and this is a little bit cleaner because the prompts are pretty much in the functions themselves now. To-do list.enter task, we enter our task, and then to-do list.sort tasks, and that sorts our tasks after they have been entered. And then we prompt enter just so we can see. System CLS toggle task completion. This displays, once again, displays the to-do list. To-do list. We enter the task number of the to-do list. As long as the input is not equal to 0, then we toggle the status, clear the system, display the updated list. Otherwise, no changes are made, and we prompt enter. And in the delete task is very similar to the toggle task completion, only instead of toggling the status, we are deleting the task completely. Going on, case 4 is the break. Default is an invalid input. And finally, we have the print calendar in case 3 of the main menu. And you saw the calendar earlier, everything is just in there. 4, initial loop is set to false, and we break, and that closes the program. Otherwise, it prints an invalid input in the default. And finally, we have our functions to save the files. Save the journal entries, save the to-do list files, and if these files cannot be saved, then we output the error message, error opening file. And finally, return 0. And that should be it.